cherry reminders. The brain. What weight? Only 2% of your total body weight, but uses more than 20% of your body energy. The answer. The most complicated body part, the brain. Wait a minute. Your brain needs plenty of energy to fuel about 86 billion neurons. These brain cells carry electric signals needed for thoughts, memories, and feelings. And the reason you can ride a bike and remember your teacher's name. Neurons form a network with more than 125 trillion connections. Your brain contains more neuron connections than there are stars in 1,500 Milky Way galaxy. This complex wiring system enables your brain to act as the control center for your entire body. This brains in one. Neuron connects the brain to the rest of the body, delivering instructions to muscles and bringing back information from your senses. They also connect three main parts of the brain: the brainstem, cerebrum. Each brain part controls basic body activities. Brainstem. The brainstem is sometimes called the lizard brain. That's because it does pretty much the same thing in lizards as in you. Control body process are essential for survival. Day and night, the brainstem keeps you breathing, digestion, heartbeat, and other automatic body processes running smoothly. Cerebellum. Every time you move your body, the cerebellum is a coordinating muscle movement. It is targeting instructions. When other parts of your brain send a movement signal, use information such as your body current, speed, and positions. With the cerebellum's guardians, you can touch your nose in one of the smooth motion. Without it, the movement would be jerky, and you might even miss the nose completely. The cerebellum also stores memories of muscles movement. Muscles memories become stronger with repetition, which is why practice has some movements, like playing guitar or skateboarding, becoming automatic. Cerebrum. The cerebrum is the largest part of the brain. This is where the most highest level brain activity takes place, including thought, speech, learning, and emotion. Cerebrum also interprets information from the senses. Sensory information reaches the brain as electricity signals, which the cerebrum intercepts as sounds, images, and other sensations. It compares the result with your electric impulse, become a purple buzz or a crowding rooster. You may be surprised to learn that knowing things is an important part of the cerebrum's job. To understand why, take a moment to notice everything your senses are communicating to you. Your senses constantly or sensing constantly food to the brain with information. By screening out something, the cerebrum helps you focus on what remains. Left, right brain, left brain. If you can look inside your head, you'll see that cerebrum is divided into two halves called hemisphere. A bundle of nerve called corpus callosum connects the hemisphere and carries messages between them. The hemisphere controls opposite sides of the body. Your left hemisphere sends a signal to raise your right hand. Your right brain is in control when you shake your left foot. Although some tests cannot be done by either semester. The two are not identical. The bright brain usually show creativity, artistic skills, and interpreting what you see. The left brain generally controls speech, writing, and math skills. Each brain hemisphere has four sections or lobes, and each lobe has a specific job. However, scientists didn't realize this until the 1800s when a doctor recorded a strange story of Phineas Gage studying the brain. Phineas Gage was injured in 1848 when an accidental explosion for 3-foot iron rod straight through his head. Amazingly, Gage survived. The hole in the head didn't affect his personality. Gage became rude, thoughtless, and stubborn, so different from his old self that his friends said he was no longer Gage. Gage has loss of portion and a form in lobe, a part of the cerebellum that governs the emotion and attention. His injury brain's regions control specific brain function. Brain mapping. The doctor studied Wade's cases for many years. Then, in 1914, World War I began. Large numbers of soldiers suffered brain injuries, and the injuries to certain brain regions consistently caused the same symptom. With the information, doctors were able to begin creating maps of brains, region, and function, trying to learn about the brain by studying brain injuries. It was much like trying to learn about coal and studying broken engines. Scientists could identify essential brain regions, but that was about it. Seeing brain activity. For a clearer understanding of brain function, they needed a way to study healthy brains. A German scientist created a machine that could measure the electricity activity in the brain. This machine, called an EEG, provided a practical solution. Everything you do, running, singing, thinking, and more, begins with tiny electrical signals in the brain. An EEG measures the signals for electrodes placed on the head surface. Researchers can see brain activities when you walk, talk, read, and more. Unless electrodes are surgically implanted inside a person's skull, though, an EEG can detect only signals near the brain surface. Observing activities deeper in the brain was difficult and potentially dangerous until a test called fMRI became available. Unlike an EEG, which measures electrical activity, an fMRI identifies active brain regions by measuring blood flow. This gave an indirect measurement of brain activity because electrically active neurons require more oxygen. Since blood is your body's oxygen delivery system, brain areas and more blood flow generally have more intensely active neurons. Unlike electrical signals, changes in blood flow can be detected deep inside the brain. An fMRI allows scientists to detect the precise brain regions used when you sing, laugh, or startle, with far more detail than an EEG can provide. Mind control. The ability to detect brain signals raises another question. It is possible to decode these signals. If a computer could decipher a brain's electrical signals, people might learn to control artificial limb or robot through a brain-computer interface. If this sounds like science fiction, think again. A filament mind control device already exists. Electrodes detect brain signal, which is used to control a mechanical device. Researchers used to control researchers hope this technology can be used to help people with disabilities move and communicate better. This technique can also be used to send brain signals from one person to another. In early experience, one person's brain signal for finger movement traveled over the internet to another room. There, a special device delivered the signal to the second person. His finger moved, following the instruction from the other brain. Maintain your brain. The brain is an amazing machine, and like a machine, it operates with proper care. How do you keep your brain in top condition? For starters, use it. Exercising your brain has discovered the same way that muscles grow with complicated finger movement for the left hand. The brain area controls that the hand is larger in most people. Brain training. Brain changes usually occur early in regions directly involved with your activity. However, researchers suggest that some mental training may cause broader change. For instance, research at Harvard Medical School showed that people who practice meditation for 8 weeks and changes in brain regions for 8 weeks and changes in brain regions used for learning, memory, and emotional control. Physical exercise, especially exercise that raises the heart rate, also has brain-wide benefits. Dr. Arthur Kramer is the director of Beckman Institute of Advanced Science and Technology at University of Illinois, where studies how exercise affects the brain. Exercise is good for your body and your brain. Kramer says research has shown that children who regularly exercise have better memories and attention and often do better on school tests. Sleep is another key to healthy brain function. According to Dr. Ken Paller, the director of Cognitive Neuroscience program at Northwestern University, evidence suggests that your brain lays memory during sleep that may help skills and information stick in your memory. However it works, it's clear that getting too sleep decreases your ability to learn and think. Perfect your brain. According to the research of Dr. Anne McKee, brain protection is the most important key to brain health. Shock-absorbing fluid, a hard skull guards your brain against injury. You land on concrete, a fall with 1, 2, or 3 feet can crack your skull or bruise the brain. Swelling inside the skull quickly cut off the brain's blood supply, and your brain can survive only a few minutes without oxygen. Wearing a properly fitted helmet during sports provides extra protection that may save your brain and your life. The brain may be the most important part of your body. Exercise, get enough sleep, and wear protective headgear to help your brain operate smoothly for years to come.